Okay, let's quickly talk about intermittent data. Not much I want to say here. So intermittent data, well, that's data that has a lot of zeros. And the classical method for that is Croston's method from 1972. So there the idea is we build two time series. Series 1, we just omit all the zeros and only model the non-zero demand. And series 2 is we count the wait time between events. So basically this series 2 is now only the zeros, but we count kind of how many zeros are there between the non-zeros, and that's the series. And now we have these two time series. We predict both of them with simple exponential smoothing. And now our forecast is the prediction of series 1 divided by the prediction of series 2. Okay, so that's a classic method, and it's actually a good inspiration for some more modern methods for intermittent data. There are these zero inflated models where you have exactly the same idea. So you have one model that predicts the probability for 0, and then you have a second model that predicts a value under the assumption that it's going to be a non-zero value. And now instead of simple exponential smoothing like Croston did it, you can use a gradient boosted tree, or whichever method you want to use, machine learning method. Another thing you can do is specialized loss functions. So for example, a negative binomial loss function, that's something that DeepAR does. You can have Poisson loss functions, or you can have a Tweedy loss function that's implemented in LightGBM as well. There are some other more specialized approaches, like this one here from Turkman et al. In 2021 that I don't want to go into. And one thing I want to mention is that it seems that different models work better depending on the degree of intermittency, right? Because intermittent can mean many things. It can mean 30% of my data is 0. It can mean 55% of my data is 0. It can mean 95% of my data is 0. And so as a rule of thumb, if you have greater than 90% zeros, it's probably better you use some kind of zero inflated type of model where you have two separate models. And if you have less than about 90% zeros, then an adapted loss function could work better. And maybe also one quick word about evaluation for intermittent data. So if you use MAE, mean absolute error, elicits the median of the forecast distribution. If you have over 50% zeros in your data, the median will be 0. So basically the MAE for intermittent data encourages you to predict a constant 0. So very often, constant 0 benchmarks are strong benchmarks for intermittent data, and you really need to think about a loss evaluation measure where the constant 0 is not just always winning. So at least don't use mean absolute error, use root mean square error, because there at least you are not eliciting a constant 0. And there could be other, more specialized metrics that might make sense for this type of data. That's it for the intermittent data. The next part is hierarchical forecasting.